Everybody, I'm Roland Vogel. I'm the Executive Director of CodeX, the Stanford Center for Legal Informatics. It's my pleasure to kick off our weekly group meetings again this year. This is our first session. And when there's nothing much left in the world that you can feel that you can rely on, you can always rely on CodeX to provide you with your fill of exciting and stimulating discussions and conversations around what's new in legal technology. So, so with that, we have, I think, an exciting couple of presentations lined up for you today, which will kick off this year of our CodeX group meeting. We have let me see, we have Georgia Volcano, who is a privacy counsel in the data protection office of Coca-Cola, who will introduce us to legal by design. And she will talk about this human-centered approach to legal problem solving. And then we have Ashkan Farhangi, who is the CEO of Canvas and co-founder and CEO of Docket Science, and also former student fellow of CodeX, who will talk about his work on machine learning Scotus prediction. So before I turn it over to our speakers, as has become customary, I want to give you all a chance to just pipe up and see if there's anything you wanted to share with the group, any news about what you're working on or anything else. Now is a good time, or you can say it or chat it. Bruce wants to share. Okay, Mr. Bruce Cahan, please pipe up. You're on mute. You have to unmute yourself. Okay, well, sorry for that.
Now it will. Sorry, Roland. Yeah, hi. Happy New Year to everybody. And I just wanted to share the space policy and finance paper that I've been working on for 6 months. Got released 2 weeks ago. I'll give a URL in the chat. And we have 5 webinars coming up starting next Thursday. For an hour with various panelists discussing it. So I'll put that in the chat.
Congratulations on finishing your paper. And that sounds like a great, interesting series of seminars. So maybe some of you folks might be interested in chiming in there. And then Shubham Sharma is writing to everyone about his paper, which I haven't had a chance to review yet. But Shubham, you wanna say a word about this?
Hi everyone, this is Sugam Sharma from Iowa State University. So I'm pretty new entrant in LI research. So I'm PhD computer science from Iowa State, but I'm trying to learn more about the legal aspect of that so I can merge them together. I'm planning to write a software, or I have written a software prototype, which will help solve some issues back in India, especially reporting the cases directly through it, rather than avoiding go to the police stations, which kind of pretty difficult back in India these days. So it's kind of nutshell. So I wrote the paper, shared with Dr. Vogel for his feedback to look at the legal aspect of that.
I will take a look ASAP. And hopefully you can present in this forum at some point. So yeah, please stay tuned. Anyone else, anything to share with the group? No. All right, well then let me turn it over to Georgia, our first speaker. There you are. Hey, Georgia. Nice.
Hi there. Hi, everyone.
Wonderful to have you. And I will turn the floor over to you.
Great. Thank you for having me here. So I will share my screen. Okay. You should be seeing it by now, right?
Yes,
Okay.
we can see it.
Perfect. So hello, everyone. I'll just give you a quick introduction about myself. My name is Giorgia Vulcano. I am Italian from Rome, in case my name and the icon weren't obvious enough. I'm a US European educated lawyer with a background in human rights and international law. Actually, I started as a human rights lawyer and then worked in global organizations and digital startups, both in LATAM and in Europe. Today, I am the privacy counsel at Coca-Cola, and I focus not only on privacy, but also on the legal and ethical implications of new technologies and on legal design, which is what I'm going to talk about today. So I'm pretty sure many of you have heard about legal design already. You probably heard about different definitions. You saw it in action in different ways. But usually when I define legal design, I refer to these three concepts. First of all, legal design is about making the law much more understandable, engaging, relatable, and accessible to people, whether lawyers or non-lawyers. And usually it refers to, visualization. It uses plain language. And in general, it aims to simplify concepts. So that's one of the aspects. Another aspect of legal design is it's really also about applying design thinking to the field of law. And finally, it's about solving problems in a creative and human-centered way. And today I will actually mainly focus on these two aspects. So the first rule of the Legal Design Club is that the word design, it's very misleading, but it doesn't really refer to graphic design as someone might think. It's not about graphic design. It's not about, the choice of colors, the icons and so on. It really goes beyond that. It's much more complex. And to that end, there's a beautiful quotation that I love to use from Steve Jobs that I think really describes this adequately. Steve Jobs used to say that design is not just how it looks like and feels like, design is how it works. So design it's a way to really reach that human centricity. It's about creating tools and solutions that are thought for humans, that are thought to solve human problems and to be used by humans. And in that end, the concept of empathy is incredibly important because it's really about understanding what others are feeling, what their needs are, what their pain points are, and it really prevents us from making assumptions. So we've been seeing so far the what, so what legal design is, but why are we talking about legal design in the first place? Well, my starting point is that the perception of value amongst people is becoming increasingly complex. When we're creating a product and a service, it's not just about making it functional or particularly attractive. It's really about creating something that is sustainable, that it embeds ethics, that it's fair. I mean, let's just look at AI, that it has a strong privacy component. But this complexity, it's not something that we can possibly address in silos. It's not something that the lawyers can work on their own, or the UX designers on their own, or the developers on their own. It requires really to have this very inclusive collaboration and to bring to the table unusual and diverse perspectives. So we looked at the what, we looked at the why. Now let's look at the how. There are many different ways to achieve this. My way is through this legal by design framework that I put together. So it's a framework that it's really shaped on, I'll make sure to zoom in a little bit more. It's shaped on the double diamond. So this funny shape that you can see right here, which is an approach that I've taken from the design thinking. And it really breaks down the process into two main phases. So one that it aims at detecting and uncovering problems and the causes to those problems. And then a second phase that's really focused on ideating and testing solutions. So that's my starting point. But to that, I've added the IRAC approach, which it's really just inspired by the IRAC. It's not exactly an IRAC application as we know it, but I wanted to shape this and format it in a way that it could be also relatable and understandable by lawyers. So what we have here is a path, is a working tool. And what I've done here is I've identified the different touch points between the legal teams and the business. And when I talk about the business, I have like a very broad understanding and definition of the business. So I mean, the marketeers, the developers, the HR people. I mean, it's super, super broad. I come from a company, so I really have more that perspective and that approach. So it's really about identifying what are the touch points and what the lawyers can bring to the table in this co-creation with the business. So like every story, this story also starts with a challenge. So usually we're talking about a challenge, a business challenge that it's particularly complex, uncertain, risky. I mean, for example, let's say we want to tackle the legal implications of remote working, or we want to apply blockchain within a section of the company for supply chain, or in a university for to manage the credentials. Or again, we want to find consensus on diverging legal perspectives coming from different jurisdictions on a common solution, for example, a cookie banner. So you can see that it's very diverse, even the application that this can have. But what counts here, what's my key message here, is that this complexity, as I was already saying before, it's not something that can be tackled by the business alone. The business cannot adequately tackle this at 360 degrees, but it needs the lawyers to jump in. So in general, what happens, right, in practice, usually you have the business that creates a business case that they validate with AT, and then they involve legal here. They involve the lawyers at the very end to ask for, an advice or the green lights. And so usually the lawyers are used to be involved at the end of the project. And they're kind of like the dream dashers. They are the Grinch taking away Christmas from the business, because usually they have to, propose advice that requires a refining and retuning of the business case that creates a loss of effort, sometimes creativity, time and money, especially when those issues could have been anticipated at the very beginning of that creation process. And so this is really what this legal by design framework aims to do. It's really about anticipating the possible legal issues, the possible legal risk at the very beginning, so that we together as one team made of legal and business, we can find a solution that is legal by design. So I broke down this into 4 main phases, right? As you can see. So we have the issue phase, the rules, the analysis, and the conclusion. So the first phase is really focused on detecting what is the regulatory and institutional framework. So it's about starting to look into what are the legal questions that are triggered by the challenge that we're looking into. And usually this phase is what we would call a divergent phase, also according to the double domain structure. So it means that it's an opportunity to brainstorm on what can be the facts and the legal challenges, what could be the relevant stakeholders, what could be maybe the lobbying effect that we should consider, what would be the authorities that are competent, and so on. So here, it's not a matter of quality, it's a matter of quantity. It's really coming up with many thoughts and ideas to share together with the whole team. And it's also about looking into what are the users' rights, what could be possible ethical dilemmas. And so this is done from both a legal perspective, but also a business perspective, because it's also about understanding what are the possible user pain points that we may encounter. And this is followed by the second phase, which is a convergent phase, and it's the rule phase. So here it's where we narrow down our findings to really identify what are the applicable laws, rules, the requirements, how do they align with our risk tolerance or appetite, what are the industry standards, what are really our obligations. So it's really about narrowing that down. And it's also about reflecting our insights. So everything that we have discovered in these first phases into what we call a legal how might we. So the how might we is also something that I took from the design thinking approach. And it's about converting a statement into a how might we formulate a question, which allows us to trigger and think about many different solutions. So in this case, a statement could be, consumers are reluctant to share their data. And the how might we formulation would be, how might we offer personalization whilst protecting the privacy of our consumers? And that's our guiding point. That is what we will be addressing, and that's what we will be brainstorming in order to find a solution. And this phase, it really helps us to focus on the causes of the problems that we want to address. So, especially as lawyers, we tend to make a lot of assumptions and to work on solutions. But actually, this approach really forces us to go to the problem and focus on the cause of that problem. And to that end, one of the tools that I use is this 5 whys. I don't know if any of you have already heard of it. Probably yes. But here, practically, what we do is we start with the problem, and then we start looking into what is causing it with these 5 whys. So let's say, for example, that the problem is that the business is reluctant to do privacy assessments and initiates them last minute. Let's just take this case scenario. I'm a privacy lawyer, so I have this privacy example. So we would ask the business, why so? And they would tell us, let's say, because they take too long. Okay. Why does that happen? Because it takes time to answer all of these questions. Okay, let's move on. Why so? Because the questions are difficult to understand. Okay, well, you got the methodology by now. Why so? Because the questions are not clear and straightforward. Okay, anything else? Well, the business does not understand all the terms used. Okay, so actually, the cause to that problem, it's not what we would have probably assumed, but it's actually very clear, and it's given to us by the end users. And it's probably the fact that the privacy assessment template that we're using is not clear to the business. They don't understand it. The questions could be simplified. And therefore, that's what actually is blocking the activity. So it really brings us to directly that problem, and it allows us to work on that particular cause. So moving on, we were saying that we were left here at the legal how might we. Well, that legal how might we is what we will be looking into the following also divergent phase, which is the analysis phase. And that's where we will start brainstorming on all the possible legal and ethical interventions that will help us solve that legal how might we. And then we will classify and prioritize them based on their impact and their effort. So usually that's at least how I do it. I use this schema, which I think is very useful, where I look into, with the team, what is the impact of that possible solution that we have been ideating, so the idea, and what's the effort required. So with the team, what we'll do, we'll start mapping those ideas around, and then we will select those ideas that have a high impact and require a low effort. So these are our quick wins that we will want to test to see if actually they can validate our hypothesis. Which brings me to the final phase of this legal by design framework, which is the conclusion. So here it's really where we detect finally what is the legal solution that we will be embedding in the MVP, so in the minimal viable product, which is a product that will embed the solution and will possibly be tested in a very low risk environment, which could be either in a country that has a less strict regime or a more favorable one, depending on what is the challenge that we are actually addressing, or maybe with a smaller sample of the population. I mean, that's where you get creative. But ultimately, we might end up with a legal advice, a new knowledge, a new discovery, or even a new product. But the key message here is that today we are facing we're working on a new generation of products that embed blockchain, that embed AI, that are particularly complex. And therefore, they pose a huge challenge to lawyers that is very hard to address on their own, because lawyers have to find a way to ensure that there cannot be an illegal use of that specific product and service. And that's where, at least from my standpoint, the legal by design approach can really help solve that issue. And so just before I wrap this up, so all of this is really open source. It's all on my LinkedIn profile. It's an MVP 1. So it's my first version of this. And I've been actually doing some deep dives on each of these aspects. So you can find already, or you can also contact me, and I'm happy to share it with you and also hear your feedback and your comments. But there is a first deep dive on really what's the vision, what I mean by this one team working together, what I mean by the challenge. And then there is a deep dive on every single one of these aspects. So you'll have a deep dive on the issue phase, which is already available. And here you also see it has suggested activities. It has questions to trigger the conversation and trigger thoughts, and the different aspects that need to be explained and explored during each phase. Same thing for the rules, and the analysis and the conclusion are a work in progress and hopefully will be published within the next weeks. So this is pretty much it from my side. I'll stop sharing in case there are any questions, but thank you everyone for listening.
Thank you, Georgia. This is great. So yeah, very interesting methodology and holistic approach. And I think also nice that most lawyers will be able to follow the IRAC kind of idea. And so I think that's very interesting. It's interesting also because I think from your presentation, it came through that, it's not always about, some technological solution or some legal solution. It could be several, it could be just advice, it could be technology, a product, it could be a new process. And I think as you evangelize this approach and others about taking more kind of a design thinking approach to running legal operations in a big organization, I think that's important. First of all, it helps your organization, I think, be more efficient as a legal department. But I think it's also good to know for people who want to sell solutions into the organization to know how you think about that. So I really appreciate your perspective there, and wanted to see if others had any questions. So one question from Rachel: would love to have your slides, and you already said that it can be found on your LinkedIn, or maybe if you could put your email address in the chat, then people could reach out to you directly to perhaps get more materials or just get in contact with you. Does anyone else have any questions for Georgia?
Could I just ask a question about the project management angle of this? Because I did a project management master's prior to starting my PhD, and it's really nice to see that the legal industry, the legal side, is picking up on those project management techniques. Have you found much resistance from people who prefer the more waterfall technique? Because you touched on it before, where you were saying that the legal team is usually brought in at the end of a project. Have you been encountering a lot of resistance from more traditional approaches?
Thank you for your question. I mean, this is really one of the many approaches, and it's actually more compatible with Agile than with waterfall, because it's meant to be used in particularly complex and uncertain scenarios. So I think it's really a different approach that applies in different and specific case scenarios. But it's a very interesting question. In general, there is always some resistance to make sure that lawyers are involved at more of an early stage. We have, everyone is so used to have the lawyers involved at the end that it's kind of like it also requires a little bit of a change in mindset and culture. But it's starting to kick off. And I think that what's always important to understand is, first of all, the needs of the project, and also the needs of the team that you work with, so that you can really adapt also to their expectations, and they're also define what is the best methodology to achieve a result.
So Georgia, I'm wondering, you know, how that, so this makes a ton of sense for a large organization with its own legal department, but how does it translate to, you know, an early stage startup that doesn't have its own legal resources yet, but has outside counsel that, you know, where I think the current situation most of the time is such that you really want to wait until the very, very last minute before you consult outside counsel, just because it's so damn expensive. And is there, can this model be translated into the, you know, the startup relationship with outside counsel somehow?
Look, it's a very interesting question, because I worked a lot with startups, and I understand perfectly, you know, how the circumstances changes, and also the limited resources. But I mean, at the end of the day, you know that you will have to involve legal, and I think that the sooner you do it, the better, because it's really my starting point. I mean, there's so much waste of time and effort to create something that sometimes you need to dismantle because it's not compliant. And again, I think that if you can, there is an opportunity for startups, for big companies, for external counsels to use this approach and make sure that they are tackling the relevant issues right from the start. So I think it really changes the moment in which the lawyers are involved. And I think that ultimately it's much more efficient, because you're not trying to put a solution to something that it's already developed and you're trying to alter that, but you're actually embedding that solution already in the product or in the service.
Yeah, Giorgio, just to tag on to that, maybe the flip is true, where lawyers can be involved in product design, like privacy by design and those kind of approaches. Maybe this is conducive to that.
Also, yeah, absolutely. I think that the approach is the same. I mean, if we want to embed a solution, whether it's privacy or it's more generally legal, into a final product and service, we have to be proactive about it, and we have to prevent it and really anticipate it in the early stages of the design, because that's where really you can maximize that effort and ensure that your final outcome is really compliant, instead of really fixing it after. At least in my experience, this has demonstrated to be much more efficient. Also because you have an opportunity to test and learn. I mean, many times, you know, we find ourselves creating the whole product, then putting it on the market or start testing it, and we realize that some parts of it don't work. Possibly they don't meet the expectations, possibly they don't meet the interest in the market, or possibly they don't meet certain legal requirements. And it's a huge waste, and ultimately I don't see the added value here. So for me, really, in order to meet that expectation of value from individuals, having legal working as an integral part of the team, instead of like, you know, that external person that no one likes and that it's kind of like pulled in at the end, I think it's much more efficient. But it's interesting to hear also how like these other perspectives, and how you are also how you have experienced this from your side.
So Scott's asking, he says, thank you, Georgia. In what ways regarding the rules phase of IRAC have you worked in multiple countries regarding the rules? So as an example, how would UBI experiments to all 7.8 billion people tied to a single cryptocurrency, such as Stanford MindPI, tied to a free universal wiki education work in your paradigm for, whoa, it's a long sentence, sorry. But anyways, let's come back to the first question. Does the rules in the cultures, you mean, you're like an international lawyer, in your IRAC system, have you observed different rules as applied in different legal frameworks and cultures?
I mean, absolutely. And even in Europe, look at privacy, and even sometimes the interpretation of certain aspects of the GDPR, they can be very divergent. And especially in companies like ours, where we need to find a pan-European solution, you have to necessarily try to match those different legal perspectives. So the rules is also part of that. It's really understanding what is the fil rouge and across those multiple jurisdictions, and also what are finally the applicable laws that you would need to comply with with your final product and service. So I mean, the rules is thought not to apply in a single country necessarily, but really to have that more of a global or pan-European, depending on the region approach.
And how are you gonna, so my next question is, now you're working for one of the biggest corporations in the world, and this is sort of like a framework you came up with. What's your strategy in establishing this at your organization? I mean, that will require some kind of cultural change, I would assume.
It does, and it's tough. You have sometimes pushback, but I also think that the starting point is always understanding the why. So why the business would not want to involve you right from the start, and really work with them to kind of like try to change that mindset. Also, because once you look, every time I've seen pushback, I think it was always really related to a lack of mutual understanding or communication. So I think that once you can get everyone on the same page, it's really much easier to overcome that resisting mindset. So I mean, that's really has been my experience. I think that this kind of methodology really allows everyone to have the same visibility. It really enables a lot of transparency, and it allows everyone to have that same understanding. So for me, it's something that I am applying today, and I can see how it's really benefiting not only the lawyer who actually can have a better visibility overall on the project, but also the business themselves. So look, it's something that you have to start with approaching the business, or approaching your clients or the students, whomever is your ultimate user, and start also seeing with them what would cause their resistance and how they can respond to this. I think it's also a little bit of a test and learning.
Absolutely, absolutely. All right, well, so we are unfortunately already sort of at the end of the time for your part of the presentation. So we should wrap it up here, but if you could post your email address in the chat, and if folks have additional questions, they could reach out directly to you. That would be wonderful. And yeah, thank you so much. Quick round of applause. Really appreciate your great work you're doing and sharing it with us. And so it's also not coming back to what I mentioned at the beginning. I think in CodeX we have like a whole variety of different presentations, and people share such interesting work. And so we started with something that's a methodology to how you make your legal counsel in an organization more effective using human-centered design principles. And we're going to switch now to a more kind of like technical presentation on how Ashkan has used machine learning to get very accurate Supreme Court predictions. So with that, let me turn it over to Ashkan. Thank you again, Georgia.
Thank you, everyone.
Wonderful to have you. Please keep us posted. And over to Ashkan. Ashkan, are you there? Hello? Ashkan? I saw you before.
Hey, sorry, yes.
There you are, okay. Nice outside. Good to see you, Ashkan. Thanks for joining us and giving us an update on your exciting work on Scotus prediction.
Yeah, absolutely. It's good to be here. It's been a while. It's good to catch up.
Right. Okay, well, over to you, Ashkan.
Definitely. One sec. Let me share my screen. I'm going to pull up my presentation. Am I coming through? Okay, seems like I'm good. Cool. So yeah, thanks guys. It's good to be here. I'm going to talk a little bit today about Scotus decision prediction, predicting the way that the Scotus decides cases using machine learning. This is a project that I did with a friend of mine from Stanford, Ajay Samshetty. We built a system and we wrote a little bit of academic content on it as well. And I'll be going through an overview of it today. So I'll start by going over the background, sort of the motivation for the problem and the problem definition, and then I'll talk about, from a slightly technical perspective, what our approach was to solving the problem. And I'll finish up by talking about what the results were and what those mean for likely next steps. So starting with background, the first question is obviously, why would anybody care? I think in this case, this is pretty obvious. The Supreme Court decides something like 80 cases per year. The vast majority of those have some sort of practical implication, whether it's for legislators making decisions, whether it's for law enforcement, whether it's for investors who are trying to predict that the way that stock prices are going to be affected by the way the Supreme Court rules on a lawsuit. There's a lot of reasons, obviously, to care. Now, the other side of this is that this idea of predicting the way the Supreme Court is going to rule, while useful, is also sort of very simple at a high level. We're just trying to predict a binary label, whether the Supreme Court overturns the case or sustains the case, or the precedent, rather. So it's a very sort of simple output that we're trying to predict, and this sort of simple output falls squarely into the model of the type of task that machine learning is pretty well suited for. Machine learning obviously is intended to make predictions, at least on the classification side, and it's a pretty standard prediction to make. And so obviously, if we're able to build a machine learning system that's able to predict the way the Supreme Court is going to rule before the Supreme Court actually rules, then for all these stakeholders who actually care about the way the Supreme Court is going to rule, this information would be useful for them to make decisions, investments, et cetera, ahead of time. And so that's sort of like the notion that motivated looking into this problem to begin with. That being said, there are actually two slightly more complicated ways to look at the problem than the oversimplified version that I just stated. Namely because the first way is to think about justice outcomes. Namely, we can think about a Supreme Court ruling as a majority vote of 9 justices sitting on the Supreme Court, obviously. And so the obvious way to sort of go about doing this task would be to look at each justice's vote as an individual variable to predict 9 yes or no's, and then compute the overall court outcome based on the majority of the yes or no's predicted on a justice-specific basis. The second way to approach this problem would be to actually just treat it as a binary classification problem and to try to predict the way the court is going to rule all in one go. So not looking at individual justices, just looking at the court as one entity and then thinking about how to predict its vote. And I'll come back to this in a second because this is going to be pretty important. But before I do, I just want to mention that we were by no means the first folks to ever think about predicting the Supreme Court's outcomes using machine learning or other approaches. This is a problem that has not gotten a ton of attention, but has gotten a fair bit of attention. And the two pieces of prior art that are sort of most significant are a system built by Dan Katz and his colleagues, and another system called Corecast. And they're sort of very different in pretty interesting ways. The system that Dan Katz and his colleagues built predicted the way individual justices were going to vote, sort of using that first model that I just mentioned. And they predicted the way justices were going to vote based on a data set called the Supreme Court Database, or SCDB for short. Now, what the Supreme Court Database is, and I'll go into this in a little bit more detail in a second, is basically just a bunch of structured attributes about cases. So it's like kind of just a big database with every row being one case and every column being an attribute like the docket number of the case, the date of the case, the justices involved in the case, the lawyers involved in the case, et cetera. Just a bunch of structured data. And they built a system where they used a pretty simple decision tree machine learning model that ingested all the structured data and predicted the way each of the 9 justices were going to vote, and then computed the way the court was going to vote based on the aggregation of those 9 justice votes. And this is pretty well, it got a lot of attention. They actually ended up building at least one follow-up system that improved on the original work. And it's sort of like the canonical state of the art of this space. A slightly less well-known system was called Corecast, and this was covered actually by the 538 blog by Nate Silver, so it didn't do too poorly either. But the system was very, very different in its methodology. First of all, it tried to predict the court's vote overall as one go instead of predicting justice votes. But more importantly, instead of using the Supreme Court database, it used transcripts of the hearings that the Supreme Court holds. And so what they did was they just got all these PDF transcripts of the hearings that the Supreme Court holds with lawyers, and using pretty much no information other than that, they just tried to predict, was the Supreme Court going to overturn or sustain? And this did pretty well too, surprisingly, and that was an interesting result. But sort of our thinking when approaching the system was that there are these two very different approaches, and there's a lot of sort of good and bad, pros and cons to each, but there's a lot of pros from both sides that can be combined to create like an even better system, and that's sort of the way we thought about it. But before we get into that, let's talk about how to define what good even means in this case. And the sort of baseline, the basis for this is the metric that we use to measure success. And this is not going to be a surprise to anybody, but the typical metric to use in this case is, in this type of problem, is accuracy, which is just the number of correct predictions made divided by the number of total predictions made. Pretty obvious. But the more interesting part of this is to think about, okay, well, we're measuring accuracy, but what actually is a good accuracy to achieve? How do we know if we've actually done well? And so the way we think about this in this type of machine learning area is typically through a combination of what's known as a baseline, a benchmark, and an oracle. And I'll go through what each of those three actually mean. A baseline is typically a system that is very simple and doesn't do that well, but is so simple that any system that is built should easily, it should easily be able to beat that baseline. It's sort of like a lower bound on how well you should be able to do. A benchmark is something like the best state of the art that's currently available. So, a pretty strong system that any new system should ideally try to beat, but, maybe not by a ton. Like, you shouldn't expect to be able to beat it by a ton because it's already pretty good. And then lastly, the oracle is sort of some like theoretical system that's really, really good that no machine learning system should reasonably expect to be able to beat, and sort of represents an upper bound on how well you should be able to do. And so typically the idea is you should, do way better than the baseline. You should try to beat the benchmark by a little bit, and you should not expect to reach the oracle, but you should hope to get as close as you can. And so in this particular case, our baseline was just the reversal rate of the Supreme Court. And what I mean by that is that it turns out the Supreme Court reverses cases about 2/3 of the time, 63% in recent years. And that's because they typically tend to bias towards only hearing cases that they're likely to reverse in the first place. And so the practical implication of that for this problem is that if you built a model that all it did was take in every case, and for every case it just spit out the prediction that the Supreme Court is going to overturn, then 63% of the time you would be right. And so, obviously that's an incredibly stupid system, very simplistic, and sort of any system that's useful at all should be able to beat that by hopefully a significant margin. The benchmark is the Dane-Katz et al. Model, because like I mentioned, that has sort of historically been the gold standard in this space. And the Dane-Katz et al. Model achieved about almost a 65% accuracy in predicting Supreme Court outcomes in recent years. And so, that's sort of what we were aiming to beat as well. And then the oracle is actually, it's a little bit ill-defined, but it turns out like some of the best human predictors of the Supreme Court are able to predict accurately about 80% of the time. And there's some debate about whether that's going to be consistent or whether there's some mean reversion that's going to happen to reduce that amount. But it's pretty clear that 80% is sort of like a very, very conservative upper bound. It's very, very hard to get anywhere near that. And so our goal was really to think about, can we like cross that 65% threshold and maybe get to 66%, 67%, something like that. That would be a success. So let's talk about how we actually went about trying to achieve that. So like I mentioned, the first thing I'm going to do is come back to this idea of whether we want to predict justice outcomes or court outcomes. And what we did was we really wanted to focus on predicting justice outcomes similarly to the system of Dane-Katz et al. And the reason that we did that was that when you sort of predict court outcomes all in one go, there's a lot of information to lose. Namely the fact that there's this notion that there are individual justices, each of which have conservative and liberal leanings, but there's also obviously a lot more nuance in the way that specific justices view the law. And so we wanted to make sure that the system that we built was taking into account all the information possible about how individual justices feel and tend to vote when trying to predict how they were going to act, and to make sure to use that information to increase accuracy instead of simplifying things a little bit more. And like I mentioned, there are sort of those two categories of prior art, the Dane-Katz et al. System being one, the court system being another, where first sort of focus on predicting cases based on structured data, the second focus on predicting cases based on transcripts. And all of them sort of use relatively standard machine learning models like decision trees and SVMs. And so the two main areas of improvement that we saw above and beyond those prior arts were first of all to increase the featurization complexity, by which I mean increasing the amount of data used to make predictions. And so, again, obviously, like the first set of prior art systems made predictions based on structured Supreme Court data, And the second made predictions based on unstructured hearing transcripts. And our idea, to start with was just why don't we combine the two and make predictions based on both the structured data and the transcripts. The second part of our room for improvement was thinking about just using more complex machine learning models and how our experience as machine learning academic, folks with machine learning academic backgrounds, how we could bring our expertise to bear in terms of improving performance through more complex machine learning as well. And what that really means was sort of moving from a model in which relatively simple machine learning models were used to do as well as possible. And instead of changing the approach to a situation in which many, many different machine learning models were considered, and all were experimented with, and the best models were chosen empirically based on how well they actually performed. And so that was a very sort of different sort of way of thinking about the machine learning problem in this case. And those are the two main areas we thought about: using more data to make predictions and being more intentional and robust about the way we chose the machine learning models used to actually make predictions. So I'll start by talking about the first, which is featurization complexity and the data used to actually make predictions. Like I mentioned, the first half of that equation is the Supreme Court database, which is actually available freely online. It has been sort of maintained by the Washington University of Law for a lot of years. They actually keep it pretty up to date, and they let anybody download a CSV containing the entire database whenever you want on the internet. I encourage you all to check it out. It's a great resource. It's really, really powerful. And what it looks like in practice is just this. If you open up the Supreme Court database in Excel, it just looks like a bunch of pretty nonsensical structured information about cases. And there's, I think about 100 columns, each of which look pretty similar to this. And to a human being, it's not that useful, but to a machine learning model that can just take all this information in, try to learn from data, and then make a prediction, it is very useful. So that's the first half of this. But to be more specific, there's all this data in that data set, many, many columns. And obviously not all of it is equally useful. And so the way we thought about this data in terms of the key subcomponents of the data that are most useful for predicting Supreme Court outcomes, it sort of breaks down into 4 categories. The first is identification, which pretty much just means having some sort of citation or docket number, some unique identifier that is associated with every case. The second is data about the background of the case. So data about, like where the case came from, the reason the court agreed to rule on it, the topic of the case in broad strokes, etc. The third is chronological information about the case, which basically just means dates related to when the case was first submitted, when it was heard, etc. And that's useful because the nature of the court obviously changes over time. And using the chronological information helps us inform how we think about the way the court behaves at that particular point in time. And then lastly, we have the data on how the individual justices and the court as a whole actually ended up ruling on the case, which is obviously the set of labels that we're trying to actually predict using the system. So that's sort of the 4 main components of the Supreme Court database in terms of broad categories that are most useful for this task. The second part of our data set was the set of Supreme Court transcripts. And these are actually also freely available on the internet. The Supreme Court actually makes transcripts for all cases in recent years available for download on their website. It's a little bit annoying because they sort of make anybody who's trying to download all these cases download one PDF at a time. So it's not a great interface. But nonetheless, there's a lot of data that is pretty freely available for folks like us who are trying to predict Supreme Court outcomes. That's a pretty good resource. What the individual transcripts actually look like is something like this. They're all just PDF documents, very unstructured, that look a lot like movie scripts in that they have names of speakers followed by words the speaker spoke. And they're just sort of pages and pages and pages of this format just going on and on and on. And every case is one of these transcripts associated with it. And so that's sort of what our data set looks like. We have the structured information on the left, and we have these totally unstructured Supreme Court hearing transcripts on the right. To use the first, we didn't really have to do a lot of work because it's already in a pretty useful format. But to use the unstructured transcripts on the right, we did have to do a little bit of work to actually make them useful. And that work starts with a little bit of pre-processing infrastructure. And so we had to do 4 things. The first thing was obviously acquire the PDFs, but the second was we had to do a little bit of work to decrypt the PDFs and convert them into plain text documents that were usable by a natural language processing system. The third thing was that we had to remove a lot of relevant content. So these transcripts have things like page numbers, page headings, authors, citations, etc. And that's all content that not only is not useful for predictions, but is very good at disrupting predictions, if not removed. And so all that irrelevant content was removed by the system. And the fourth and last part of the preprocessing infrastructure was doing a good job of taking all those individual words that were spoken and associating every word spoken with a structured representation of the speaker who spoke it. And so what that means is that we took, every sort of sentence in the entire transcript, and we associate it with one of the lawyers or one of the justices on the Supreme Court that we believe, based on our analysis, the PDF transcript is saying spoke those words. And this is what really sort of connected the transcripts to the Supreme Court database, because the Supreme Court database has all the structured data about these justices, these lawyers, in a structured way. The transcripts have no structure. And what we did was we took all these individual words spoken and associated them back with the canonical IDs of the justices and lawyers that were represented in the Supreme Court database. But that's sort of just the infrastructure step. The next step, and also the final step of making the transcript data useful, is to extract actually useful signals from those words that were spoken. And there were a lot of different signals that we experimented with, but the 5 most useful and interesting were the following. The first is just the number spoken by lawyers on each side. It turns out that the more time a lawyer is given to speak, the more justices likely think that they're saying interesting things, and therefore the more likely they are to be right and end up winning the case. On the other side, you also have the number of lawyers spoken by justices to the lawyers. And that's pretty similar. It turns out the more a justice speaks to a lawyer on one side, the more they're feeling compelled by their arguments, and the more likely the lawyers are to win on that side. The third is a little bit more interesting. It's looking at the number of times that justices cut off or interrupt lawyers on each side. And it turns out that for pretty intuitive reasons, the more justices cut off lawyers on one side, the less likely they are to side with that side, because interruptions are indicative of disagreement. And I think there's a saying out there that apparently, an interruption by justice is a bad sign, but an interruption by Ruth Bader Ginsburg is an incredibly bad sign. And so that's an interesting sort of anecdote that actually ended up being a little practically useful in our system as well. The fourth is a little bit more complicated. It's sort of this notion of sentiment index towards lawyers. And what that means is that we took all the words spoken by justices to lawyers of each side, and we did a little bit of basic sentiment analysis to understand for each one of those sentences spoken, was that sort of like a positively leaning sentence or a negatively leaning sentence? And we sort of computed this average notion of how positive the speech of the justices was when speaking to each side of the case. And obviously, the more positive sentiment is when speaking to you, the more likely you are to win. And then lastly, we had this notion of weasel words, which comes back to this idea of weasel words in natural language processing, which is this notion that if when a person is speaking, they're using qualifiers like I think, I've been told, etc., basically these phrases that convey doubt, it's more likely that the person speaking is either lying or at least, they're probably wrong. And so we looked at the number of instances in which lawyers of each side were using these weasel words as a signal of them being less likely to actually win the case. So we kind of combined these 5 notions and then a bunch of other slightly more arcane ones into a structured data set of attributes about the hearing transcripts, add that data to the Supreme Court database, and kind of ended up with this really big data set of data related to Supreme Court cases. And where this ended up was sort of this architecture where we, first at the very top of the system, started with transcripts in the Supreme Court database. We did a bunch of preprocessing work to combine that into one cohesive data pipeline. We did some preprocessing, featurization, ultimately split that data up into training data sets and validation data sets to actually measure accuracy. And then did a bunch of experimentation with different models where we looked at different models and sort of empirically understanding how well each one of them was going to perform on this task, which I alluded to earlier. And I won't go into the detail, but there are a lot of different models and hyperparameters of models that we experimented with to make sure we robustly identified the best ones. So I know I'm running out of time here, so I'm going to quickly end by talking a little bit about how all this worked. And so the sort of more complicated answer that I'll start with is that it really depended on which model we actually used. On the screen, I've displayed the performance that we achieved with a bunch of different pretty standard models. And as you can see, there was a lot of variance. Some models actually did significantly worse even than the baseline, which is surprising. Some models did sort of as well as the baseline, and a few models did better than the baseline. And the one I really want to focus on is a voting ensemble classifier, which is a classifier that took in predictions by several of the other classifiers and made a meta prediction by looking at the way the majority of the more simple classifiers were voting in terms of what they thought was going to happen. And that classifier not only achieved a 3.5% delta over the baseline, but it did about 2% better in terms of accuracy than even the benchmark, which was the Dan Katz et al. System. So from our perspective, that was a pretty good outcome, and a pretty good indicator that this was a successful work, at least to some degree. The other conclusion I want to point to quickly is that while the voting ensemble classifier did extremely well, surprisingly, the neural network model actually did not. And this really caught us by surprise, but the neural network model did a little bit better than baseline, but actually did worse than the Dan Katz et al. Model, even though the Dan Katz et al. Model was using a significantly simpler machine learning model. And our conclusion based on this was that it's likely that this is just a problem space in which the additional complexity of neural networks is not only not useful, but is a detriment to performance, because what's sort of happening at a fundamental prediction level is so simple that a simpler model is better able to represent what's going on than the really complicated neural networks. And so that was an interesting conclusion of this work. I do have a few slides on future work that could be done to improve this model, because while we're pretty happy with our performance and we sort of empirically not only beat the baseline, but the state of the art, the oracle is quite a bit better than what we achieved. And so the fact that we have that 13% or so delta with the oracle means that even though we did pretty well, there's a lot of room to do even better. And so there's a lot of work that we might do, somebody else might do, I think somebody will do eventually. But in the interest of time, since we only have 4 minutes left in this meeting, I think I'll skip that and go straight to questions, just to make sure we have a few minutes left for that. So with that, thank you guys for listening.
Yeah, fantastic presentation and such interesting work. And this is the work that came out of your fellowship at CodeX. It's research that was CodeX research, and yeah, I'm very, very proud of this work. People have a number of questions. Miriam is asking, legal scholars tend to be very good at predicting legal outcomes. It is their job. Hence, why AI attempting to predict has to somehow either be faster at predicting or more accurate. Any thoughts on that? It's more a comment than a question.
Yeah, it's a great question. The goal is ultimately to be more accurate. And the notion is that sort of by virtue of the fact that machine learning and computer systems can be faster than people, they should be able to use a much larger amount of data than a human being is able to feasibly use, just by virtue of time constraints and the amount of information we can all hold in our brains. And so the idea is that done well, a system like this should be able to use a lot more data and therefore ultimately be significantly more accurate in terms of prediction.
Cool. Let's see. Thibault is saying, hold on. What has proven to be the most important in your experiment? Gathering great data or using an efficient ML technique? Have you been focusing on one aspect over the other?
It's a great question. Empirically based on our studies, we found that gathering more and better data was by far the more impactful aspect of the work.
Cool. And Lance is saying, sharing a paper that he wrote on AI for legal judgment prediction. So check it out. He kindly put a link there. And Thibault is following up with a question on, have you also considered the fact that some algorithms may suffer from not being given the right data? If so, how did you try to adjust the data?
Yeah, we didn't, because we really only had access to the data that was out there, and we tried to use everything that we could get. Okay. And so our job was to do as well as we could with that.
Okay. Carl is asking, is the data set shareable?
Yes. I actually have posted it on GitHub, so I'd be more than happy to send the link out.
All right, super, thank you. And
Ashkan, could you just drop your email into the chat before the meeting ends so folks can be in touch?
Yes, absolutely.
Cool, thanks.
Then Robert is saying, is the data set in RDF format?
I'm sorry, could you repeat that?
Is the data set in RDF format?
RTF format? No, it's the raw data is in PDF format, and there is some open source code that does the work of transforming that to raw text data.
Okay. Carl is also asking, did you measure the information gain of individual features?
No, that's a great idea, but we have not done that yet.
And Miriam's asking, have you thought about having the predictions of your model voted on by humans to better train your AI predictions?
No, just because we sort of believe like the best prediction is just, whatever the Supreme Court actually did. Human predictions are sort of a little bit worse than that.
Okay, and Bruce is asking, how might this be used to name and quantify judicial bias or myopia?
Yeah, I mean, part of what we did was we actually built models that sort of attempted to predict the way that justices would lean in terms of specific cases and topics. And so in a lot of ways, we're reverse engineering the way that justices have bias. So yeah, there might be something there.
Huh, cool. Well, good. Well, great. So that brings us pretty much to the end of our time. Thank you so much, Ashkan, for sharing your work with us. It's a very cool project, and
definitely.
And it's a really great presentation. Also, to Georgia, thank you again for sharing, and it's really wonderful. Great way to, I think, kick off this year, and appreciate you all who joined us for this session. Taking a short leave from CNN or whatever your TV channel of choice is, and I thought that was really, really refreshing. Great way to start the year. I appreciate it. And Susan, do we have a presentation lined up for next week already?
We do. Yeah. So we'll see everyone next week.
All right. We'll send out an announcement ASAP. And good to see you all. And see you next time. And stay safe in the meantime. All right, you guys. See you later. Take care. Bye-bye.
Bye.